On board were 206 passengers and 19 crew members. At 15:08 local time, the Boeing 747-209B pushed back from the gate and climbed into clear skies. Shortly after, the aircraft vanished from radar screens. Within seconds, debris began falling into the Taiwan Strait, 23 nautical miles northeast of the Penghu Islands. All 225 people on board were killed instantly. What broke apart that aircraft was not a design flaw, not a manufacturing defect, and not pilot error. It was a repair decision made 22 years earlier, a repair so inadequate that it became a time bomb ticking away beneath the fuselage with every pressurization cycle. The story begins 2 decades earlier, on the 7th of February 1980. The same aircraft, registration B-255, was operating Flight 009 into Kai Tak Airport in Hong Kong. During landing, the pilot rotated the nose too high on touchdown. The tail skid hit the runway hard, scraping and gouging the lower aft fuselage. The damage was assessed. It looked like a dent, a scrape, fixable damage. The aircraft was ferried back to Taipei without pressurization. A temporary repair was installed on 8th of February using reinforcing doublers made of 7075 T6 aluminum, each 0.063 inches thick. The repair was approved by the Boeing representative on site. In May 1980, the aircraft returned to the hangar for the permanent fix. Here is where the chain of decision-making began to break. Boeing's structural repair manual was explicit. Damaged fuselage skin in that location must be trimmed out and replaced with new skin. The manual existed for a reason. It ensured the load-bearing integrity of the pressure vessel. China Airlines engineers, however, chose a different path. Instead of cutting out the damaged section and riveting in new skin, they installed a doubler plate over the existing damage. The damaged skin remained underneath. The repair was documented minimally and classified as minor rather than major. Because it was minor, no detailed configuration was recorded. Boeing was never formally notified that the permanent repair had been completed. The aircraft returned to service on the 25th of May 1980, exactly 22 years to the day before it would break apart in the sky. What happened next was silent and invisible. With each flight, the aircraft pressurized and depressurized. Each cycle created tensile stress on the fuselage skin. The doubler plate design had created a stress concentration. The loads were focused at the edge of the repair, right where the original damage still lay beneath. The microscopic fractures at the damage site began to propagate. Millimeter by millimeter, year after year, a crack grew through the metal. The aircraft completed over 64,000 flight hours. It took off and landed more than 21,000 times. It passed C-checks and heavy maintenance inspections. Visual inspection, the standard maintenance tool, could not see what lay beneath the doubler plate. The corrosion prevention and control program had gaps. Documentation lapsed after November 1997. No one knew the crack was there. The flaw was becoming catastrophic in silence. On the morning of 25th of May 2002, B-255 was prepared for another routine service. The flight plan showed normal weight and balance. The crew completed their pre-flight. Passengers boarded, settled into their seats, and the aircraft pushed back on schedule. The climb to FL 350, 35,000 feet, was routine. The cockpit reported normal operations. During the cruise to Hong Kong, the aircraft was operating smoothly. The flight data recorder and cockpit voice recorder showed no anomalies, no warnings, no hint of the structural catastrophe about to unfold. At that moment, the fatigue crack beneath the fuselage was approximately 71 inches long, well beyond the 58-inch threshold at which the fuselage loses its residual strength under normal pressurization loads. The aircraft was flying in a state of structural failure. The crew did not know. No warning light illuminated. No system alerted the pilots. The damage was simply there, silent, waiting. At 15:37, 4 minutes after leveling off at cruise altitude, the fuselage failed. The fatigue crack propagated rapidly across the aft lower fuselage. The pressure vessel fractured. The cabin, pressurized to 8 pounds per square inch, met the near vacuum of the stratosphere in an instant. Explosive decompression tore the aircraft apart. The structural failure was catastrophic and instantaneous. The aircraft broke into multiple sections and fell into the Taiwan Strait. First responders found wreckage scattered across the sea. The identification process took months. Of the 225 people on board, 175 of the remains were eventually identified through visual identification, fingerprints, dental records, and DNA analysis. An entire aircraft, 225 human lives, erased in seconds. Not because of a flawed design, not because of impossible conditions, but because a repair made 22 years earlier had not been done to specification. The Aviation Safety Council of Taiwan took charge of the investigation. It would take nearly 3 years, until 25th of February 2005, for the full accident investigation report to be released. The report, designated ASC AOR 502001, was comprehensive and unflinching. Investigators reconstructed the wreckage. They examined the fracture surfaces with magnification. They measured the crack. At the moment of breakup, the continuous crack ran at least 71 inches across the aft fuselage. The fretting marks on the doubler plate and the deformed cladding on the fracture surface told a story of repeated stress, repeated flexing, repeated failure of adhesion between damaged skin and reinforcement. The investigation traced every decision back to 1980. It examined maintenance records. It reviewed inspection protocols. It documented where the system failed. The investigation revealed systemic failures. The 1980 repair had been classified as minor, which meant minimal documentation and no requirement for detailed configuration records or formal Boeing approval. The repair deviated from Boeing's structural repair manual, but because it was undocumented and informally reported, no oversight authority caught the deviation. Maintenance inspections relied on visual methods, technicians looking at the surface. A doubler plate bolted over the damage created a visual appearance of a normal repair. Beneath it, fatigue was advancing. The corrosion prevention program had gaps in documentation in later years. No mandatory inspection specifically targeted the repair zone after that date. The aircraft underwent C-checks and zonal inspections. All of them missed the crack because the crack was not visible without removing the doubler or using advanced inspection techniques like ultrasound or eddy current testing, tools that were not part of the standard visual inspection routine. The Aviation Safety Council's final finding was unambiguous. The in-flight breakup of China Airlines Flight 611 resulted from a fatigue fracture in the aft lower fuselage skin, initiating beneath an external doubler plate that had been installed during a non-conforming repair in 1980. The inadequate repair, combined with insufficient maintenance inspection, allowed a structural defect to remain hidden and grow for 22 years. The Council issued 21 safety recommendations addressing structural repair standards, fatigue assessment procedures, maintenance documentation rigor, and inspection methodologies designed to detect subsurface cracks that visual inspection cannot reveal. Those recommendations were directed at China Airlines, the Civil Aeronautics Administration of Taiwan, Boeing, the FAA, and other aviation authorities. The message was clear. A shortcut taken in 1980 had killed 225 people in 2002. China Airlines Flight 611 stands as a case study in how maintenance discipline and documentation rigor are not minor administrative tasks. They are matters of life and death. One faulty repair classification, one decision to use a non-conforming method, one gap in documentation, one assumption that visual inspection would catch hidden damage. Each link in the chain was individually small. Together, they killed 225 people. The investigation forced aviation authorities worldwide to strengthen structural repair standards, improve documentation requirements, and mandate advanced inspection techniques for critical areas. Boeing and the FAA implemented stricter oversight of major versus minor repair classifications. Airlines were required to close gaps in corrosion prevention programs. The doubler plate itself was not inherently dangerous. The danger came from using it as a shortcut instead of following the established structural repair manual. Modern aviation is safer because of the hard lessons learned from this accident. Those 225 people cannot be brought back, but their loss created knowledge that has prevented countless future accidents. That is the only meaning we can make from this tragedy.